Another alternative of naming alcohol, we can also use the common names. Okay, berbeza dengan IUPAC system which includes the number, the common names can only be applied towards a simple alcohol. When I mention the simple alcohol, it refers to alcohol which contain less than 10 carbon attached to it. Other than that, we're going to mention the name of the homolog series, which in this case, the name will end up as alcohol, as long it contains the carbon attached to the OH group, or we call this as the carbinol, the combination of carbon together with the hydroxyl group. Okay, so let's take a look at some of the examples. For instance, if we have two carbon which attach to the OH, if we refer to the IUPAC name, okay, the numbering will be position 1, which closest to the OH, and 2 is the continuous carbon chain which attached to the carbon number 1. If we are using the IUPAC system, the name will be called as ethan 1-ol. Since the first carbon is attached to the functional group, we can ignore the number 1, so we can also name it as ethanol. For this naming, we replace the A and E from the alkene into ol, so it becomes ethanol. So what about the common name? So for the common name, as long as you have a structure of carbon which attached to the alcohol, we're going to assume that compound is an alcohol. So we just write down the homolog series, which is alcohol, and then we're going to name the alkyl attachment, which is positioned at carbon number 1 and number 2, and for 2 carbon, it will be considered as ethane. We're going to change the A and E into the alkyl attachment. Therefore, the A and E will be converted into YL, so this will become ethyl alcohol. Okay, let's take a look at another example. Let's say we have carbon with 3, we have an alcohol with 3 carbon, and then it attached to the OH. So number 1 is closest to the OH, number 2 in the middle, followed by the third carbon. So based on the IUPAC system, there are 3 carbon which is attached to the OH group in a linear form. This will be called as propan 1-ol. Again, since it's located at the first carbon, we can ignore the number 1, and then we can write it as propanol. So what about the common name? The common name, again, as long we identify the attachment of carbon with the OH, we know that this is an alcohol. Okay, and any carbon attachment to the alcohol will be named as an alkyl group. So we have 3 carbon, which is propane. We're going to convert it into an alkyl group, therefore it will become propyl alcohol. Please make sure there is space between the 2 words. Okay, propyl alcohol, there will be 2 words. Now let's see what happens if we change the position of the alcohol group. So let's say we have the same number of carbon, which is 3, but now the OH is positioned at carbon number 2. It will be looking like this. So based on the IUPAC system, this will become propan 2-ol, which indicates that the position of the alcohol is located at the second carbon. You can also use the old IUPAC system, which will be called as 2-propanol. For the common name, what's going to happen is the same, which is the OH is attached to the second carbon, Since it is also carbon, we know that this is from alcohol group. Okay, so how do we name this? It still have 3 carbon. However, it is positioned at the second carbon which attached to the functional group. For this one, we still use propyl. However, to differentiate it with the former structure, we need to put iso at the front. So as you can see here, this structure will be named as isopropyl alcohol. We cannot simply use propyl alcohol because this will be referring to the linear chain alcohol. So as you can see here, for the IUPAC name and the common name, for the IUPAC name we have numbers, while for the alcohol we just put the iso to indicate that this is the isomer of the propyl alcohol. Other structure that you need to know is like this one. The IUPAC name will be butan 1-ol, or preferably written as butanol. The common name will be butyl alcohol. Again, please take note that the alcohol is referring to the main functional group, while butyl is the conversion from the 4 carbon, which is butane, into an alkyl group of butyl. Other examples: the name for this compound is butyl alcohol. Again, the alcohol comes from the OH with the carbon attachment, while butyl because the OH which attached to the second carbon is attached to 2 carbon, which make it as a secondary alcohol. That's why the word is butyl alcohol. Other than this, we can also have isobutyl alcohol, and we have butyl alcohol. So please take note the position of the OH and then attachment to the carbon chain. As you can see here, isobutyl alcohol is a primary alcohol, third butyl alcohol is a tertiary alcohol, while butyl is secondary, and butyl alcohol is a primary alcohol. As I mentioned before, the common name can only be applied to a simple alcohol. So let's take a look on how to name a larger alcohol by using the common name systems. So let's say you have 6 carbon and then the alcohol is attached to the second and also to the third carbon of the structure. So for the first one, the IUPAC name will be hexane-2-ol, and then the common name will be hexyl alcohol. This is because the carbon which attached to the OH is attached to 2 carbon. So for this one, we can also call it as sec hexyl alcohol. Why? Because it also have the COH which attached to carbon, which is also a secondary. That's why for a larger structure or larger carbon chain, sometimes we cannot apply this common system. That's why it is preferable to use the IUPAC system which has a numbering. So what if we have a cyclic compound? For a cyclic compound, I'm going to show you two examples. First one is cyclopropane. The other one is cyclohexane with the OH. For the IUPAC name, this will be called as cyclopropane, and the other one will be called as the name should be cyclopropanol, and the other one will be cyclohexanol. By using the same rules, okay, we have the OH attached to the carbon, so this will be alcohol, and then the cyclopropane will become cyclopropyl. Again, we convert the alkene group into the alkyl group, which have the YL at the back. For cyclohexanol, the cyclohexane will become cyclohexyl. Okay, make sure you got the correct spelling. And then don't forget the alcohol homolog series, which referring to the attachment of the OH to the carbon. Remember guys, this can only be applied to a simple carbon chain without any other substituent. This is the limitation of the common name. And finally, for aromatic, we have benzene, which attached to the OH. The IUPAC name that we're going to use is phenol. But for the common name, we can also use the similar guideline. First, we have the carbon attachment to the OH, which is alcohol. Now the benzene will be converted into alkyl group, which is the benzene act as the substituent, will be called as phenyl. For the last part of the video, I'm going to leave you with the questions. How do you name this compound? You have a benzene. It attached to a carbon first, and finally it attached to the OH. For the IUPAC name, the name will become 1-phenyl methanol, because the OH is attached to the one carbon, and the one carbon attached to the benzene, which acts as the substituent. Please figure out what is the best name of the common name for this compound. Okay, if you have any question regarding the common name, please leave a comment. Please leave a comment on the section given, or discuss it in the Telegram group. That's all for this video. See you in the next video. Goodbye.